Okay, so this is we're gonna be doing office hours here. This is and we're going to go through the glider private pilot um written exam, the FAA written exam that every new private pilot has to take before they can get their license. We're going to go through the exact materials that you can use, the format of the test, and how to do it. Okay, so let's start off with just a little bit of format here. Okay, so the here are your when you go to take your test. Here is the info you're going to get and you're going to need. Okay, so let's put this on this screen so everyone can see it. Okay, so here is the FAA knowledge test matrix, which gets updated periodically throughout the year. When you go to take your test, you need your FTN number, your federal tracking number, which you get when you get your when you sign up for your student pilot's license. You can always find it in Niagara. Then you need valid ID with your photo on it, and that's usually your driver's license or permit. Okay. Now let's take a look at the private pilot exam. Okay, for gliders. Okay, number of questions 60. You could take it starting at age 14. You have 2.5 hours to do it. And as with all other FAA written tests, 70% is what's needed to pass. Okay, that's 70%, not 70 questions right, because obviously there's less questions than that. Okay. And when you show up, make sure to bring your logbook that has an endorsement from an instructor um, certifying that you are authorized to take the test. Okay. So that's what the test looks like. Now, let's talk a little bit about the materials you can bring. Okay. The FAA specifically tells you what you can and can't bring. Okay. What are the test aids that you'll be given? What are the test aids that you can bring with you? Okay. Bottom left here, guidelines for use of test aids and materials. Applicants may use test aids such as scales, straight edges, protractors, plotters. So you want to bring your plotter, which has a straight edge. Okay. Navigation computers. I recommend just a traditional E6B, but if you use one of the electronic computers, this is a Sporty's one, ASA makes one as well. Those are allowed, and all models of aviation-oriented calculating devices. Okay, navigation computers, all models of aviation calculating devices. Okay. And those can have the manufacturer's permanently inscribed instructions are permissible. So when you're when your E6B or other navigation computer literally has instructions, words on it for how to use it, you know, here's how to use it. Let's flip it around so it's actually like readable. But here's how to use it. It's got instructions at the top. It's got other instructions here for different equations and formulas. All of it is permissible. Okay. The test proctor may provide an additional calculator device. They'll usually provide a 4-function calculator of some kind. Today, we're going to use just the one on the computer just to be able to show our work so you can see it more easily. But that's part of that. Okay. Here is the knowledge test supplement. That'll be provided during the test. Bring yours with just in case. I have never had someone show up to a test and the test center said they didn't have it, but in case they don't, you want to bring this with. Okay. And you should be using one of these at home anyway, because the charts and the maps on the inside are printed at the proper scale. If you just use the PDF, while it's free, You won't be able to practice properly because first of all, it's really hard to put a plotter up against a screen and measure something up against the screen. That just doesn't work. And then also, you're not ever quite sure if the map is at the proper. Also, one of the things we're going to be doing during this test is a lot of times the questions will ask for a specific figure, um, but they'll assume that you know all of the information from the front of the of the um, of the knowledge supplement, and they won't tell you to go there to look for certain types of information, but it's all here. And if you have a physical copy and are learning from it, you'll know exactly where to turn for some of that additional information that the FAA won't point you towards during the test. Okay. Now, also you'll be given usually a stack of. They'll give you a stack of printer paper. Okay, you can ask for as much as you want. They'll give you a couple sheets to start off with, and then also some mechanical pencils is what they'll give you there. Just some regular mechanical pencils for you to use during the course of the test. Okay, 2.5 hours is what you're allowed for the current private pilot's exam for gliders. They're reducing it. They've already reduced it for airplanes. They're going to. I think they've also reduced it for gliders as well. Excuse me, for helicopters as well. But right now it's still 2.5 hours for glider private pilot exam. Okay. So we're going to go ahead and take a test together. So I recommend using ASA's prepware, particularly on mobile devices, iPhone or Android. And we're going to take a test, and you just select which one you want, Private Pilot Glider, okay, and start. Okay. And we'll just start a timer on that. We have 2.5 hours. Should be able to do it in less than that, even with discussing it all. Okay. So let's start off going through this together. Refer to figure 23, area 3. The top of the group obstruction, approximately 11 nautical miles from the Savannah vortex on the 009 radial is, okay. So I'm going to look at that, and I'll bring it up on the screen as well. But figure 23, it's easiest to just bring it up immediately so you can be looking at it. Okay. Area 3 on the 11 nautical miles from the 009 radial off the Savannah vortex. Okay. So let's show that. So let's zoom in on that. Okay, here's area 3. There's your Savannah vortex. It even says Savannah right there. Okay. And the vortex is located on the field there. Okay. It looks like it's located at that dot. Where that dot is. Okay. And then 009. So it's almost due north. So the arrow points points north. So 009. Remember, each one of these is worth you got 360 or 000, 30 030, 60 060. Okay. So each one of these tick marks is worth 5 degrees. So 5, 10. Okay. And then right now, that's where it's useful to use your plotter and make sure that you're using the proper scale on there. Okay. So when I line it up with 10, okay. Sectional 10 on the sectional side. Okay. That 11 puts it just beyond where the rosette circle is. It puts it right up here. Okay. And they're asking for the height of the group. Okay. Not 8, 9. And it's just about right here. So it looks like they're referring to that group. Let's just check the question. Always answer the question they're asking. Okay. The top of the group obstruction 11 nautical miles from the Savannah vortex on 009 radial is. And remember, radials always radiate. So you're always going from the center of the radial because you're radiating outward. Okay. They give us three options 400 feet AGL, 432 feet MSL, or 454 feet MSL. Be very careful of those numbers because they will try to trick you with that. The group obstruction. Okay. Looks like that one to me. This group obstruction right here. Okay. 454 feet is what I see directly underneath that item right there. It's a group obstruction, 009. It's about 11 nautical miles. Okay. And I read it right there 454, and there some smokestacks is what they've got right there. And that's MSL because when you read a number right off of here, okay, that's how high it would be on your altimeter. Okay. They don't want you having to do math in your head. Okay. This one here, where it's got something in parentheses, that's the AGL. We're looking at the MSL. Okay. So they're making sure you know how to read the chart. And they say group obstruction, right? Yep, group obstruction. 454 feet MSL. Next. What action should the pilot of a glider and an airplane take if on a head-on collision? Well, this is your right of way question. And we know that we yield to the right. If you're on a head-on collision, you might say, "Well, the airplane's more maneuverable than me, so they should get out of the way." Um, um, in reality, you should both get out. The airplane. Okay, the answers are airplane should give way to the left. That's not correct. The glider pilot should give way to the right, or both pilots should give way to the right. Okay. If you're on a head-on collision course, you should both give way to the right. Okay. Yield to the right. Yield to the right. The greatest vortex strength occurs when the generating aircraft is light, dirty, and fast, heavy, dirty, and fast, or heavy, clean, and slow. The greatest vortex strength. So this is wingtip vortices is what they're asking here. Okay. So your wingtip vortices, light or heavy? Well, if the aircraft is heavy, it's generating more lift. So therefore, definitely the greater or vortex strength will happen when it is heavy. Okay. Dirty or clean? So that's saying, are the gear and the flaps out, which is dirty when the gear and the flaps are down, or when it's clean when those are pulled up into it. Well, when the aircraft is in a dirty configuration with the gear and the flaps downward, okay, what happens is that prevents air from flowing around it. So the flaps and the landing gear tend to actually decrease vortex strength. Okay. And then slow versus fast. When it's slow, it's at a high angle of attack, generating lots of lift, generating more induced drag, high angle of attack. So that's definitely the answer there. Okay. The development of thermals depends upon a counterclockwise circulation of air, temperature inversions, solar heating. Oh, thermals come from solar heating. You don't get thermals at night; you get thermals during the day. Temperature inversions kills thermals. They go up and then they stop right at the inversion. Counterclockwise circulation of air. Talking about, I don't know what they're talking about there, but that's not the right answer. Clouds, fog, or dew will always form when water vapor condenses, water vapor is present, relative humidity reaches 100%. Clouds, fog, or dew will always form when will always form when I'm gonna can't remember exactly which one they want you to answer on this. We're gonna say because what it is clouds, fog, and dew form. But it's the dew. The dew. Okay, water vapor condenses. Relative humidity reaches 100%. You won't get dew with 100%. It's got to condense. That's dew is on, not just suspended in the air, but it's actually on top of something. Okay. When converting from the true course to magnetic heading, a pilot should. This is where it's really handy. This they're not saying look at your computer, okay? But this is a question where it is actually to look at your computer, okay? So let me put it up to the screen there. So the question is, when converting from true course, okay, to magnetic heading, MH, okay, a pilot should always do you subtract or add? Now, that's what they're asking about. Subtract easterly variation, right wind correction angle, add easterly variation and subtract wind correction, or subtract westerly variation and add wind correction angles. Don't try to remember the formulas. Have it on your calculator and or particularly that's why I like E6B. I could just read it right off of here. So when I'm going from true course, as the test as it says, true course, TC, right here. Okay. Okay. When I'm going from true course to magnetic heading, all the way over here to magnetic heading, what do I do? Okay, true course. First, I've got my wind correction angle. Then I've got my, and that gives us true heading, and then we take the variation into account. So what do I do for? Let's get this right up there on the thing. Okay, so let's read that as questions. When I'm going from true course to magnetic heading, what do I do? Subtract easterly variation and right wing correction. Okay. Well, it says plus R, so I add um right wind correction angle and variation, subtract east variation. Oh, yep, it says minus E. Okay, yep. So half of it's wrong, so therefore it's all wrong. Add westerly variation and subtract left wind correction angle. Okay, wind correction angle, subtract left wind correction angle. Variation, add westerly. Oh, add westerly variation. Okay, that looks good. So probably number 2, subtract westerly variation, subtract westerly. Oh, nope, that's not right, right? We add westerly variation and add right wind correction angle. Okay, so that one has half wrong, so that was all wrong. So it's definitely number 2. Just look at the E6B. Okay. Refer to figure 27. An aircraft departs an airport in the Central Standard Time Zone at 08:45 Central Standard Time for a 2-hour flight to an airport located in Mountain Time Zone. The landing should be at what coordinated universal time? Okay, so we go to the map of time zones for the country. Okay. Okay, starts at 08:45 CST, 2 hours. Okay, just writing this down so that way I don't have to jump back and forth between the question um and the um and the book. Okay, so we start in Central Standard Time. Hey, look, there's it even says right there Central Standard Time, and we're going over to Mountain Standard Time, right? Mountain Standard Time. Yep, Central to okay. So we start in Central. 2 hours later, start at 8:45. 2 hours later. Okay. And then they're saying, what is the Zulu time? Okay. Well, we went over one time, and they've got this little chart down here that says, how do you convert from one time zone um, to to UTC, to Zulu time? Okay, and that's what we're going to use the end at the end. Okay, so we're going to go over from Central Standard Time, and it's going to take us 2 hours. So if we're starting at 8:45, okay, so 8, and we'll add 2 hours. So by the time we get there, 8 plus 2, now it's 10:45 in the morning, Central Standard Time. Okay, come right over to the chart, Central Standard Time, add 6 hours. Okay, so by the time we get there, it's uh it's uh, um it's 10:45 Central Standard Time because we left at 8:45, and now we add an additional 6 to that. I think that's the easiest way to think about this one. 16:45 Zulu time, or UTC. Okay, if you want to think about it as well, I started at 8:45. 2 hours later would be 10:45, but subtract an hour. Now but I actually arrive in Mountain Standard Time at 9:45 by 8 plus 2 hours later minus an hour for the time zone change. Now it's 9:45. You can still do that. You just add 7 to it right there. Oops, woo. 9 plus 7 equals 9 plus 7 still equals 16. Okay. 16:45 Zulu. Okay. To act as pilot in command of an aircraft carrying passengers, a pilot must show by logbook endorsement satisfactory completion of a flight review or completion of a pilot proficiency check within the preceding. Okay. How often do we need flight reviews? This is just really, the question is really, how often do you need a flight review? Okay. And it's 2 years. It's every 2 years. Okay. The old BFR. Now it's just called flight review. Before it was a biennial flight review every 2 years. Okay, refer to figure 50. The segmented circle indicates that the airport traffic is. Ooh, segmented circle question. This is going to be good. You're going to see these a lot. Almost every field, you're always going to see these. Okay, over to figure 50. Okay, left hand. Okay, so they're asking about figures. Okay, let me just write this down so I can show you the picture while reading it off. Okay, left hand for runway 36 and right hand for 18, 18. Left hand for runway 18 and right hand for 36, or right hand for 9 and left hand for 27. Runway 27. Okay, let's take a look at the figure. Okay. Okay. Here is your they have a little windsock. They can ask you about that on other questions, but here they're just asking about um, uh, the segmented circle itself. Remember, the north points up. I remember first seeing one of these charts. It was like, well, which ways? I don't know which. None of them are labeled. I don't know what's going on exactly. It's like, well, there's north up. Okay, once you see that north up, then you know what way it is. Okay, so the first one was, and remember, left hand versus right hand. If I put yourself in the glider and fly along these L's and then figure out which way do you have to turn. Okay, if I'm coming down and then if I want to go and I have to turn left to go towards the airport. So this is left-hand traffic. Okay. On here, if I'm coming along the L, I have to turn right and to go towards the airport. That's right-hand traffic. Okay, the first one is left-hand traffic for 36. Okay, 36 is straight north. Okay, left hand. Okay, I like it. Okay, right hand for 18. 18 is going south. 18 is south. Okay, so right hand. Okay, well, it's probably the first one. Next one, left hand for runway 18. Okay, if I'm coming here, if going down to 18 south, if I turn right, no, it's not a left turn. It's a right turn. Boop, right turn. Okay, and then right for 36. Con- they're trying to confuse you. Remember, runway headings are always labeled with the direction you're going when you land. Okay. And then the last one, right hand for runway 9. So 9 is your landing towards the east. Okay, that's not a right hand turn. That's a left hand turn. And then a left hand turn for 27. You go around. Okay, 0, 90, 180, 270. Okay, well, you have to turn. If I'm coming down to go 270, okay, I have to turn. I'm going down and then I turn to the right. That's not. So it was the first one. It was always the first one. Okay. Next. Which condition results in the formation of frost? The temperature of the collecting surface is at or below freezing when small droplets of moisture fall on the surface. Okay. The temperature of the collecting surface is at or below the dew point of the adjacent air, and the dew point is below freezing. Okay. The temperature of the surrounding air is at or below freezing when small droplets of moisture fall on the collecting surface. Ooh, this is a tricky one. Very small differences, but that's what if they're asking. Really, do you understand how frost forms? Okay, frost when the temperature of the collecting surface is at or below freezing when small droplets of moisture fall on the surface. Okay, frost. Remember, it's not snow. Snow is when the water freezes in the air and then falls to the ground. Frost is when it turns to ice when water freezes on the surface. So, number one is correct. The temperature of the collecting surface is at or below the dew point. Okay, if it's at or below the dew point, that means you'll get dew, you'll get water, liquid water, but not. And then they also say a point of the adjacent air and the dew point is below freezing. Um, and the dew point is below freezing. That's no, no. The temperature of the surrounding air is at or below freezing of the surrounding air when the droplets of moisture fall on the collector. Okay, well, if the air is at or below freezing, you get snow or ice crystals. Same difference. Okay. To get a complete weather briefing for a planned flight, the pilot should request a general briefing. That's not a thing. An abbreviated briefing. That's not complete. That's abbreviated. Or a standard briefing. Standard briefing. So these questions that are just like they ask you, do you know a fact? Okay, they're just seeing if you know the terminology. Um, those ones go very fast. Not each. You're not going to spend the same amount of time on each of these questions. How far will an aircraft traveling in 2.5 minute an air travel in 2.5 minutes with a ground speed of 98 knots? Okay, so this is where your E6B comes into becomes comes in handy. Okay, which I put down right underneath the book. Okay, so on our E6B, we're gonna rotate the wheel 98 knots. Okay, 98 knots. So I rotated it such that right here there's 90, that'd be 100, and then I've rotated the miles per hour. Trying to get that into focus. No, that's not good. That's better. Okay. 98 knots. Okay. Then I just go around it and I look at um 2.5 minutes. Okay. And again, E6B tells me, you know, oops, let's get it there so I can actually see it. Autofocus is having some issues. Minutes are above, hours are below. It even just tells me that. So 2.5. 2.5. Okay. Okay. So you don't have, so here I'm going to look at 25. It's really, we'll figure out. Okay. There's 25. Okay. So then that 2.5, 2.5. 2.5 minutes is 2.5 minutes. Okay. We look on the outer scale, four, almost 40. There's 440. There's 50. 45. 4045. Okay. And it's the 2.5, 2.5 reads just below the 4.1 spot. Okay. Or just around the 4.1 spot. Let's take a look one more time. 98 knots. 2.5. It's almost right on the 4.1. So, yeah, just below 4.1. Yeah. And we have one. 4.08 nautical miles. Okay. On speed questions, what is the first thing you always do? Put the speed in. Put the speed in on your E6B. One of the most easily recognized discontinuities across a front is change in temperature, an increase in cloud coverage, and increase in relative humidity. Okay, well, it's a front. Okay, what kind of fronts are there? There's warm fronts and cold fronts. So that's what we talk about. We talk about mostly warm fronts and cold fronts. One of the most easily recognized discontinuities across the front is a change in temperature, going from warm to cold or cold to warm. FAA advisory circulars, subject matter specifically related to airmen, um, are issued under which subject number? That one is, so these are the general headings, and they follow the same example as the FARs. So just remember, you get your certificate under FAR 61, and you operate most of the time under 91. So certificates, airmen, okay, and getting your certificate, that's going to be in the 60s, okay. Whereas operations is going to be under 90. Rules of the road is 90. Okay, but we're asking about airmen right now. What causes an airplane, except a T-tail, to pitch nose down when power is reduced and controls are not adjusted? So just remember, you're saying, well, power, but this is a glider. Yeah, but you could be flying a self-launch glider, a motor glider, and which, so you do have to know some facts about airplanes, and they'll use airplane interchangeably with glider. Okay, so you think about a propeller; it's forcing additional air over the over the wing of of the aircraft. Okay, and so when you get when the propeller is going, it's a giant fan and it's blowing extra air over the wing, which is creating additional lift and on the wing, and then it's also creating additional downforce from the horizontal stabilizer on the tail. Okay, which cause an airplane except a T-tail, because T-tails have a high the horizontal stabilizer that is high up on a T-tail. Okay, looks like a T at the back of the aircraft. Okay, why does it cause it to nose down? Well, you're getting extra air over that tail, and that tail is power is reduced. So normally you've got air coming over the tail, and then you reduce power. Well, you're putting less air over that tail, So the downforce is going to go down, and that's going to cause it to pitch forward. Okay. CG shifts forward and thrust and drag are reduced. CG didn't shift. You just reduced power. CG didn't change. The downwash on the elevators from the propeller slipstream is reduced, and the elevator effectiveness is reduced. Okay, that's the answer. When thrust is reduced to less than weight, what? Lift is also reduced, and wings can no, 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 no. Okay, it's a giant fan in front of the aircraft. When you turn it off, it it you have less downforce in the back. Okay. Refer to figure 3. Altimeter 3 indicates. Okay, this is how to read a clock, which is an altimeter. An altimeter is a clock is an altimeter. Okay, how do we do that? Okay, we're going to go to figure 3. Figure 3. Okay. Altimeter. Okay, and they have 3 options. I'll write them down here so I don't have to go back and forth. 9,500 feet, 10,950 feet, or 15,940 feet. Okay. And it's number 3. We're looking at number 3. So, smaller hands indicate bigger things. So, you can kind of see, let's zoom in here. Okay, here's number 3. You can see there's letters and words underneath the altimeter. Okay, that's kind of your guide. If you ever get, you can go to these other ones to see what it's actually saying there. Okay, it's saying that the covered a little bit. It's showing that littlest hand represents 10,000 feet. The hour hand, what you normally think of as the hour hand, is the 1,000-foot, and then the minute hand is just hundreds of feet. Okay, so we look at it. We can definitely tell that the hour hand is between the the 9 and the 0. Easy. Okay. So it's 9,000 something. Okay. All right. 900 something. Excuse me. No, I was right the first time. Yeah, 9,000. 9,000. Okay. 9,000. Okay. The littlest hand for 10,000 feet, it's right at the 1. Okay. Is it a little bit before or is it a little after? It's really hard to tell. They're trying to trick you by having it point almost right at it. But you know for a fact, because it's pointing right at it, it's got to be really close to 10,000 feet. That littlest hand is pointing there. This is one where they try to get you with this. Is it pointing above or below? Well, if it was above, it would have to be like way above to get to that 15,900 number. Okay. It's pointing almost right at it. So we know it's about 10,000 feet. Okay. Your thousands of foot marker um, is is between 9 and the 10. Okay. And then hundreds of feet is on the outer marker. Okay. That's for the minute hand there. Okay. So let's go ahead and take a look. Okay. So I'm saying it looks like it's definitely not 20,000 feet, because if this were 19,000 feet, this would be pointed way over here. It's not 19,000 feet. So it's got to be 10,000. Well, if it's 9,000 to 10, okay, then this has to be pointed slightly below it. It's got to be 9,500 feet. And that's pretty darn close to 10,000 feet. Okay. This is how you check yourself. 9,500 feet. Which is true concerning the blue and magenta colors used to depict airports on sectional aeronautical charts. This is the easy way how you cheat. Okay. Airports with control towers underlying class A, B, C, A, B, and C airspace are shown in blue. Class D and E airspace are magenta. Ooh. Okay. Airports with control towers underlying C, D, and E are shown in magenta. Airports with control towers underlying B, C, and D and E airspace are shown in blue. Go to your legend. This is where it pays to go to the legend. Okay. In fact, we'll bring that up here in just a second. You go to legend 1. It's the first thing. Okay. Right here. Oops. Legend 1, sectional aeronautical chart. And it's going to tell you everything you want to, almost everything you want to know about sectional aeronautical charts, just like the question asks. Okay. So let's see. Okay. Airports with control towers. Airports. Let me see if I can find it on here. I'm trying to find the specific spot where I expected to tell it. Okay. Oh, there we go. There we go. I saw it now. Okay, I'm going to bring it up on my screen here. So that way it's easier. Supplement. We want the supplement. Test supplement. Here we go. So I'm going to bring this up on the other screen so that way it's even easy. It's easy to see this. Okay, here it is. I'm going to go to, just so it's easy to see it. Okay, here it is. They don't tell you to look inside your sectional, inside your test supplement. The answer is right there if you're willing to look at it. Okay. Okay, let's zoom in on this and then we will read it. Okay, legend. Let's zoom in on it a little bit more even. Okay. Where's my hand tool? I want the hand tool. Look at where it says legends. Airports having control towers are shown in blue. All others in magenta. That's it. That's the answer. Okay. Airports having control towers are shown in blue, all others in magenta. So we go back, which is true concerning blue and magenta colored airport colors to depict airports. Airports with control towers underlying A, B, and C, doesn't say anything about A, B, and C in that legend, are shown in blue. That is kind of true. C and D, no, it doesn't say anything about that. It says tower versus no tower. Okay, airports with control towers underlying. Why is it saying underlying? With control towers are shown in magenta. Nope, doesn't say that in the legend. Airports with control towers underlying. Okay, just you can even forget that underlying thing. Just shorten that sentence. Okay, it's true that it is under class B, C, and D, but it's always true. This is always true. A, B, C, D, and E. That's this is everywhere. Airports with control towers are shown in blue. Number 3. They're trying to trick you by trying to make it by making you think about airspace, and that is not what it's about. Refer to Figure 20, Area 4. What hazards to aircraft may exist in restricted areas such as R5, R for restricted, R502B, and they tell you it's a restricted area anyway. So, so this you can look at it. We can look at it. Area 4 down here. Okay. Hey, look, there's a restricted area. It's in blue. Okay. But you need to know that it's restricted. Okay. And that you just need to remember what the difference between restricted and MOAs and different types of airspace is. So about restricted military training activities that necessitate aerobatics or abrupt flight maneuvers. That sounds like a MOA. Unusual, often invisible hazards such as aerial gunnery or guided missiles. Okay, that's restricted. Okay. Um, High volume of pilot training or an unusual type of aerial activity. That'll be they'll have some kind of a warning area for a special warning area um, on that. But restricted. Why would they want to keep you out? Period. Um, Missiles, guided missiles, and aerial gunnery. That would be the answer there. VNO. Okay, is defined as VNO. Okay, well, let's just go down the list. The normal operating range. That's the green arc. Okay. That's the green arc. This is talking about a specific speed on your airspeed indicator. Okay. So if we take a look at a normal airspeed indicator, um, I'm going to, just for the sake of showing it, I'm going to do it with figure 4 just to show it. Okay, you don't have to look at this when you're doing it on yours. When you're doing it on your test. Okay, I'm going to go to figure 4. Okay, zoom way out. Okay, let's put this around so you can actually see it. Okay, so the options are. Figure 4 is where I want to go to. Oh, please, you're taking forever. 1, 2, 3, 4. Okay, figure 4. And we'll zoom in on that. Okay, normal operating range, VNO. Well, VNO doesn't, is the normal operating range is your green arc right there. The VNO does not specifically do that. Never exceed speed. Never exceed. VNE. That's VNE. So they're trying to trick you there with VNE and VNO. Okay. That's your red line, VNE. Okay. And then the last one, maximum structural cruising speed. So that's actually the transition. Okay. The green arc is your normal operating range. They didn't ask you about that. They asked about VNO. And NO does stand for normal operating, or at least it used to. It used to stand for normal operating. Now it's just maximum structural cruising speed is what they want to call it now. So to differentiate it. Okay. So maximum structural cruising speed, a specific speed, it has to be a specific line on here. Okay. VNO is going to be your maximum structural cruise speed. If an emergency situation requires a downwind landing, so landing with the wind rather than into the wind, a pilot should expect a faster, so if you're landing with the wind, okay, airspeed, a pilot should expect a faster airspeed at touchdown. Okay, no, you're going to touch down at the same airspeed. The airspeed indicator is going to read the same. A longer ground roll, that actually would be true because you're landing with the wind. And better control throughout the landing roll. No, it's going to be worse because the wind is coming from behind you, and so it's making your controls less effective. You want the air coming over front to back, not back to front. Okay, the air pilot should expect a faster ground speed at touchdown. Yes, a longer ground roll. Yes, and the likelihood of overshooting the desired touchdown point. Yeah, that could absolutely happen. The last one, ground speed higher. The pilot should expect a faster ground speed at touchdown. Yes, a shorter ground roll. No, you got the wind behind you. You're going faster over the ground, and the likelihood of undershooting the desired touchdown point. Yeah, you're not going to undershoot when they got the wind from behind you. Okay, they're saying, do you understand that we always land into the wind, and landing with the wind is a lot more difficult. We avoid it whenever we can. What antidotal phrase can help reverse the hazardous attitude of macho. Okay, antidote phrase. They want the antidote phrase, not what is macho. I can do it. That is macho. Taking chances is foolish. Okay, or nothing will happen. Okay, two of those are hazardous attitudes, and the other one is an antidote. Okay, antidote is how you correct for it, or and at some point in your flying, you will be repeating these to yourself and be like, "Oh man, I need the antidote." And we'll say it. Taking chances is foolish is the antidote. Okay, for the macho attitude. Which operation would be described as preventative maintenance? Okay, this is in part 43. Go over that during ground training. Okay, replenishing hydraulic fluid. Okay, preventative. Yep. Repair of a portion of the wing skins. Okay, we're talking preventative maintenance. Repair of portions of of skin sheets by making additional seams. Okay, that's repair. Okay, right there it says. Okay, repair of landing gear struts. Okay, these are those last two. They say repair in the answer, so you know it's not that because that's trying to fix something. We're trying to talk about preventative maintenance. Okay, replenishing hydraulic fuel fluid that naturally just goes down over time. Yeah, that's preventative. Okay. Referring to figure 54, how many feet will the glider descend at minimum sink speed for 1 statute mile in still air? Ooh, this is a good one. This is understanding L over D, and it's also about um, um, understanding how to read the chart. Okay, so we're going to go 1 statute mile. 54. Okay, so at minimum sink speed, okay? So min sink, 1 statute mile is what we go. 1 statute mile. How far down? In feet. So we're also going to have to convert miles to feet, feet to miles, okay? So now the nice thing about this chart okay, is you kind of get uh they give you what it is. So you have two lines here on this chart. You've got your L over D. Okay, that's your glide distance, and then you've got your sink speed. So if we're at minimum sink, and they tell us minimum sink is at 44 miles per hour. You need to use these charts some to be able to get familiar with them, so that way you know where to look on the chart to get the information you need. This is why you gotta have the book. You just buy a copy of the book. It's like 10 or something bucks on Amazon. I'll put a link in there. Okay. So at 44 miles an hour, what now that they're trying to use the sink versus lift, because now you've got your min sink here. Okay. That number there below is not the line you want to look at. You want to look at the green line above. That's your L over D. So, but we want to go start at 44. Okay. 44 right there. Okay. We come up from 44. Zoom in there. It's between the 42 and the 46 line. Okay. We come up from between 46 line. Okay. That looks about halfway between 42 and 46. Okay. Then we're going to move over to the side from there. Up. It's between 28 and 30. So it's 29. Our L over D is equal to 29. Or you could also think of it as 29 to 1. Okay. So if we go 1 mile, okay, and the problem is we're going to go sideways 1 mile, and then we're going to go down some amount of feet. Well, that's L over D. What that is the same as we're going to go 1 mile. How many feet is a mile? Because they give answers in statute. 1 statute mile is 5,280. Okay, hard for me to show my paper, but it's 5,280 divided by that. Oops, I say 30. 5,280 divided by 29 equals 182 feet. 182 point, yeah, 180. Okay, closest answer. If receiver autonomous integrity monitoring RAIM capability is lost in flight. So they're just telling you RAIM. What does RAIM even mean? Well, it's in they're trying to confuse you straight up front, but that's each of the answers there says GPS in it. RAIM is GPS, is making sure that you have a valid GPS signal. Okay, if you lose contact with the satellites, you do not have GPS navigation. Okay, so the pilot. Okay, if RAIM capability is lost in flight, the pilot may still rely on GPS derived altitude for vertical information. No, you just lost RAIM. Okay, the pilot has no assurance of the accuracy of the GPS position. That's true. The GPS position is reliable provided at least 3 GPS satellites are available. No, it's not actually. What the way the GPS works is, remember, it uses 3 GPS satellites to get your position, but then it needs a fourth one so that way it can vote to figure out if one of the GPS satellites is in error. And so we don't just use 3; we use 4 at a time. 3 to get your position, and the fourth one to vote to make sure that the others are telling the truth. So if you lose RAIM, you have no assurance of the accuracy of GPS. Okay, coming up on the halfway point, about 50 minutes in. And remember, we're talking through it. If you're reading these, it goes a lot faster. Refer to figure 55, illustration 2 means, okay, oh, these are hand signals, the signals for tow. Okay, we either release, first one is release the tow line, ready, or hold position. Okay, so we're going to look at number 2 on 55. Okay, let's zoom in on 2. Okay, starts with 1, obviously, in the top. Okay, 2. Okay, so release, that'd be cut. That's this guy right there. That's release. Okay, ready. Hold is let's see if we have yeah. Hold position there. Okay, that would be hold position. Would be arms up. Okay, that's number 7. Number 4 is take up slack. Okay. Number 2 is ready, and what it is it's showing your arms or the wings of the glider, and they're horizontal. So normally you can see even in the picture there, you've got one wing on the ground. Well, he's not ready. Okay, but if the wings are level, then you are ready. So it's saying ready. Okay, ready to tow. No person may operate an aircraft in formation flight over densely populated area in Class D Delta airspace, except by prior agreement arrangement with the piloting command of each aircraft. So no, it's C. No stealth formation flying. Everyone has to agree to it. Okay. The correct method of stating 4,500 feet MSL to ATC is, so that now it's just how do you talk? How do you speak on the radio? Okay, this is radio terminology. Okay. 4,500. 4.5, no. 4,500. That's the correct one. 4.5, nope. 4,500 feet. Oh gosh, no. 4,000. We separate thousands from hundreds. 4,500. Okay. Basic VFR weather minimums for operating at an aircraft within Class Delta airspace are 500-foot ceiling and 1 mile visibility. That would be awfully close. Okay. 1,000 feet ceiling and 3 statute miles visibility, or clear of clouds and 2 miles of visibility. Um, we're gonna, yeah, it's the second one there. Those other ones sound ridiculously dangerous. Okay, except when necessary for takeoff or landing, an aircraft may not be operated closer than what distance from any person, vessel, vehicle, or structure. Okay, takeoff and landing, it's 500 feet. This is just you remember it, 500 feet. Okay. Referring to figure 17, determine the wind and temperature aloft forecast for Denver at 9,000 feet. So Denver, 9,000 feet. Okay. And then we just have to read it. Okay. It's going to be one of those read ones. Okay. So here's our winds and temperature loss forecast. Denver is the third one, 9,000 feet. Okay. So they tell you a little bit in there about what it is. So temperatures, if you look above, temperatures are negative above 24,000 feet. We're not there, so we don't have to worry about that. But they're always going to be negative above 24,000 feet. Okay, well, so it's really, do you know how to read aviation weather, which is important because that's how you'll be reading it. That's presented for in pilots in a very short form, so that way you can do that. Okay. Well, we can see that there's that to the right. There's a plus versus minus. Well, if there's plus or minus, that means temperature. Okay. So we can already see -4 degrees Celsius right there. Okay. And then remember, they always give you the wind direction, then the wind speed. So it's coming, and they drop the 0 at the end, just like they do with runway headings, so that we know that. So it's 230 degrees, okay, and the wind speed is 21 knots, and the temperature outside at that altitude is -4 degrees Celsius. Okay. So first, they try to confuse you with magnetic versus versus is it magnetic? Winds are always given in true direction. Okay. We said it was 21 knots. They're saying 53 knots. I don't know where that's coming from. And 47 degrees Celsius. I don't know where that's coming from. That's not right. Okay. 230 degrees true. 53 knots. Where's this 53 coming from? It's probably from a different slot. Okay. Last one, 230 degrees true. 21 knots. Temperature -4 degrees C. That's exactly what we were saying. Okay. When we looked at the chart. Referring to figure 15, in the TAF, the Terminal Aerodrome forecast from K, Oklahoma City, the FM from group is forecast from the hours. Okay, this one, they're asking you a specific time. They are going to try to trick you with different times within this one. From 1600, okay, 1600 to 2200 Zulu. Okay, and it's Oklahoma City. Okay, Oklahoma City. Okay. So we look at the right one first. Don't look at Memphis above. Look at Oklahoma City. Okay. So they're going to say when was the TAF given? Okay. When is it valid? It's valid from the 5th at 1200 to the 6th of the month at 1800. Okay. So do we want to start at 1200? The question said from 1600. So we look at, okay, hey, look, let's look around here just for some other examples. Yeah, there's only the one from group. Okay, from on the 5th at 1600, okay, we've got winds, 180, 10 knots. Again, just from the last question we asked, okay, it's always the direction, then the speed at 10 knots, KT. They even tell you 10 knots. Okay, 180, 10 knots. Okay, we got plus greater than 6 statute miles, P for plus 6 statute miles to visibility. Skies are going to be clear, and then it's becoming from 0 on the 5th from the 20 at 2200 hours to the 5th at 2,400 hours. Well, that's outside the range they asked about. They only asked about from 1,600 until 2,200. It's becoming that's part of 20. That's beyond 2,200. That's the only part that they're asking about. Okay, the knots are 180 from 180 at 10 knots. Okay, plus 6 statute miles visibility and skies clear. Okay, that's all there is to it. Okay, so 160 at 10 knots. No, we said 180 at 10 knots. That's what we read. 180 at 10 knots. Okay, that's okay. Becoming. No. That's outside the time that we cared about. Wait a minute. 2,200? Yeah, right? And then 180 at 10. Okay, so look at one more time. Just gonna second guess myself. Becoming 2,200. Nope, that's 20. That's outside the range they're asking for. Becoming at 2,200. They're just asking for this. Okay? 180 at 10. Okay. Only answer the question they asked. It's very common with these things. Okay. When telephoning flight service for a pre-flight weather briefing, the pilot should state whether they intend to fly VFR only, that they possess a current pilot certificate, um, the full name and address of the formation commander. What the heck is that? Okay. Whether they intend to fly VFR only. Okay. They're going to ask you what type of flight it is. If you don't say that you're going to fly VFR, they're going to ask you because they will read it as from a VFR standpoint as opposed to an IFR standpoint. Okay. When landing behind a large aircraft, which procedure should be followed for vortex avoidance? Stay above its final approach path. That sounds good. All the way to touchdown. Okay, yeah. Stay below and to one side. Oh, that sounds terrible because the vortex is going to come downward, and you don't want to be flying underneath it because then there's the vortex, and as you come in underneath it, if you're trying to come underneath it, you might run into it. That's bad. Okay, still well below it. Its final approach path. Okay, that's okay. That's the second one is bad, and the third one is worse. Okay, it's stay above it all the way to touchdown. How can you determine if another aircraft is on a collision course with your aircraft? Ooh, this is optical illusions and visual separation question. The other craft will always appear to get larger and closer at a rapid rate. Actually, it looks very tiny for most of the time, and then it gets bigger very quickly right at the end. Will always appear to get larger. It doesn't appear to get larger and closer for the most of the time. But the nose of each aircraft is pointed at the same point in the sky. Not necessarily true. If you're converging with another aircraft, okay, um, your noses don't have to be pointed at the same place. They can absolutely be pointed in different directions. Okay, there will be no apparent relative motion between your aircraft and the other aircraft. That's the correct answer there. A lack of orientation with regard to the position, attitude, or movement of the aircraft in space is defined as spatial disorientation. Disorientation. Are you a lack of orientation with regard to position, altitude, or movement of the aircraft in space? Lack of orientation of the aircraft in space. That's spatial disorientation. Is literally in the name. Okay, spatial disorientation. Hyperventilation. That's just breathing too hard. Breathing too hard. Hypoxia is lack of oxygen. Hypoxia. That has nothing to do with those other things. For private pilot operations, a second class medical certificate issued to a 42-year-old pilot on July 15th this year will expire at. This is one of the unfortunate parts of the knowledge tests for gliders is the you say, well, you don't need a medical certificate. That's true for gliders, but the FAA lumps all of the health and medical certification questions together. And so instead of looking at individual questions saying which should and shouldn't be on the test, instead they say, well, health should be on there and pilot physiology it should be on there. So they put all the questions in there. So you actually do have to know about this, even though you don't need a medical to fly a glider. Okay. 4, private pilot certificate operations. A second class. Okay, so and the thing is on this, a second class medical, um, oh gosh, the number of different things in here, none of which you really need for a glider. So the person's over 42, okay, and it's a second class medical, but they're saying that it's also just for private pilot operations. So you're not going to be exercising commercial privileges, okay? You're going to be exercising private pilot privileges. Um, okay. And okay, and then they say it's on it was issued to a 42-year-old, so they're above 40, and it's on July 15th. This year will expire at okay. So first of all, remember medical certificates always expire at the end of the month that they were given in the future. Okay, they never expire in the middle of a month. They'll always expire at the end of a month. Okay, so July 15th. Yes, July 15th. Ooh, I saw July 15th. I'll think July 15th. No, 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 no. Okay. Um, um, so that one already is out. Doesn't matter. Okay. Now it's July 31st or July 31st. 1 year later or 2 year later. For people over 40, a second class medical will last for 1 year. This is not a great question, but you're going to see them on the knowledge test. So you have to know it at least for the knowledge test, and then you can kind of forget about it. With certain exceptions, Class E Echo airspace extends upward from either 700 or 1,200 feet AGL to, but does not include, okay, 10,000 feet MSL, 14,500 feet MSL, or 18,000 feet MSL. Okay, and you're gonna say, oh man, and what they're really asking is what is the overlying airspace? Okay, so it's really saying where they're trying to trick you with a couple different things here, but if it's going from Class E airspace and it's going upward, okay, um, it's going to say what's above Class E airspace. Well, the thing that's above Class E airspace is Class Alpha airspace. A alpha altitude. That's 18,000 feet. Okay, Class A airspace starts at 18,000 feet. That's what that question is actually asking you. Okay. Under what conditions will true altitude be lower than the indicated altitude? Okay. In colder than standard air conditions, in warmer than standard in colder than standard air temperature, in warmer than standard air temperature, or when density altitude is higher than indicated altitude. Okay, so this is high to low. Watch this is the old rule of thumb, the old mnemonic. Just remember high to low, look out below, low to high. You're clear in the sky. Okay, and the way they ask these questions are super confusing, I find. So I always try to write it down to create a little chart for myself so I know what to do. Okay, so under what conditions will true altitude, your actual altitude, be lower than your indicated altitude? The density altitude is higher than the indicated altitude. Okay, so I like to write, will the true altitude, your actual altitude, be lower than what's indicated there? Okay, so I write, I'm going to write indicated altitude above, and then I'll write true is below it. Okay, Okay. And colder than standard or warmer than standard. Okay. Your true. Okay, so high to low, look out below. That would say your true altitude is um, your true altitude, your actual altitude is lower than the indicated altitude. Okay, so in colder, from high temperature to low, colder than standard, that's when you need to be worried. Okay, density altitude. No, 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 no. Okay. Each person operating an aircraft equipped with ADS-B out must operate this equipment in transmit mode at all times. That's true. When flying in controlled airspace. Okay. At all times at and above 10,000 feet MSL. Those are all true, but the most true one of them is at all times. Okay. Remember, sometimes you're going to see, oh, there's more than one correct answer. You want to pick the most correct answer. Okay. At all times. Referring to, okay, we're 2/3 of the way through, and we're just at an hour and 9 minutes right now. 2/3 of the way, and we haven't even used half our time. Okay, and I'm reading through each one. Okay, refer to Figure 20, Area 2. The flag symbol at Lake Drummond represents a. Okay. Okay, and then what are the options they give? Let's look at the options first. Compulsory reporting point, or a visual checkpoint. Okay, compulsory reporting point for Norfolk class Charlie, compulsory reporting point for Hampton Roads Airport, or a visual checkpoint used to identify position for initial call up to Norfolk approach control. Okay, Lake Drummond. Lake Drummond. Okay, Lake Drummond, right there. Lake Drummond. Okay, and you see this little flag. Okay. Okay. There's a little flag there at Lake Drummond. If you look at the beginning of your test supplement, okay, again, we go back to the test supplement. Hey, look, there's that little flag. Huh, wow, miscellaneous. Okay, name, VP, visual point. These are visual reporting points that you are seen on sectionals. VP stands for visual point. These are visual reporting points. It's very easy to identify Lake Drummond from the air. And so these are points that ATC has to memorize that we say, hey, I'm over Lake Drummond. They get tested on what those visual reporting points are, and they're expected to know them. So if you call up and say, hey, I'm over Lake Drummond, or they'll say fly to Lake Drummond, that's what it is. Okay, so let's go back to the question. Okay, compulsory reporting point. No. Oops. Let's go back to that right there. Okay. Compulsory reporting point for nope. Compulsory nope. Visual VP visual checkpoint visual point used to identify. Okay. You identify a position for initial call up to Norfolk approach control VP. Okay. Ooh, looks like we get another one. Figure 23. The flag symbol at Statesboro Bullock County Airport, Claxton Evans County Airport, and Ridgeland Airport are the flag symbols at those three airports. At Statesboro, Claxton, and Ridgeland. Okay. The flag symbols. Okay. Oh gosh. Okay, we just said that. Okay. Hey, look, Claxton. Okay, Claxton Evans. Statesboro, Bullock, and what's the other one that has a flag on it? Clacks, and then Ridgeland, as they said the other one was Ridgeland that had a flag on it. Where is Ridgeland on this map? There's Ridgeland. And Ridgeland. They've got that little flag symbol, okay? Outer boundaries of the class of Savannah class Charlie. Nope. Airports with special traffic patterns. Nope. Visual checkpoints. VP. Visual point. Visual checkpoint. Look at the legend. To identify positions for initial call up prior to entering Savannah Class E. You say, hey, I'm over, Claxton Evans. I'm over Ridgeland. They know where those airports are. Okay. You're both talking about the same things if you're using VFR visual checkpoints. Refer to figure 25 area 8. What minimum altitude is required to fly over the Cedar Hill TV towers in the congested area south of Dallas Executive? Okay, we're going to go south of Dallas Executive. RBD. Okay, minimum altitude is required to fly over the Cedar Hill TV towers. Okay, and that's area 8. Okay, area 8. Hey, look, Cedar Hill. Area 8, Cedar Hill. Okay. So we got some towers here at 2,549 MSL. We got some more below it at 2,449. So you want to pick the highest of these. Okay. Hey, look, this one here, 2,549. It looks like that one's going to be the tallest. Okay. And it's south of Dallas Executive, which you can see is Dallas Executive, just by the number 3 right there, RBD. So, okay, the minimum altitude required to fly over the Cedar Hill TV towers in the congested airspace. Okay. Fly minimum altitude is okay. So they're asking for a minimum altitude, not necessarily a safe altitude. They're asking for a minimum altitude. Okay. They have one of the numbers is 2,655. One of them is 3,549, 3,449. And they're all MSL, which kind of makes it easy. Okay. So you're going to ask which is the best of those. Okay. So we zoom in again one more time in there. Just look at it. Okay. So the minimum altitude to fly over them of those, yeah. Now you want to fly over those with plenty of altitude, but if you're coming in for a landing somewhere, maybe you're not be able to fly over them at the minimum altitude. Sometimes you got to fly over them closer than that if you're landing either at Dallas Executive or to the south, Eagle's Nest or Moonbow or whatever. Okay, so if we just need to get over them, that 2,655 is going to get you over them. Okay, but I would definitely want to fly over them higher than that. Okay, why should you file a VFR flight plan with the FAA? Okay, you're required to do so when flying beyond 25 nautical miles from an airport. Nope, not true. To provide traffic reports with the flight service. Nope, not true. To provide search and rescue in the event of emergency. If you don't show up, they're going to use your flight plan to know where you went to come look for you. Okay. What minimum flight visibility is required for VFR flights on an airway below 10,000 feet? Okay. Okay, you're on an airway, not just class Gulf airspace. It's going to be actually on an airway. Okay, 3 statute miles. Okay, for class G airspace, just out in the middle of nowhere, then it would be 1 mile. But when it's on an airway, it's going to be 3. Okay, which type of weather briefing? Oh, we're 3/4 of the way through. Which type of weather briefing should a pilot request when departing within the hour if no preliminary weather information has been received? No preliminary weather information has been received. Outlook briefing. Okay, Outlook is far in the future. Abbreviated. Oh, you received no preliminary weather information, so you want to ask for a full standard briefing in that case. When the term light and variable is used in reference to winds aloft forecast, the coded group and wind speed is 9900. Okay. Light and variable is less than 5 knots. And so it's going to be the 9900 there. Okay. Doesn't know the direction, but it knows that the wind is very slow. When an ATC clearance has been obtained, no pilot in command may deviate from that clearance unless that pilot obtains an amended clearance. The one exception to this regulation is when the clearance states at pilot's discretion and okay, no. If you're doing it at pilot's discretion, are you really deviating from it? An emergency. The one you can always do anything in an emergency. If the clearance contains a restriction, when can deviate it. No pilot may deviate it. The one exception is the clearance restriction. That's part of the clearance. No, an emergency. You can always deviate from a clearance in an emergency. Okay. Someone's going to hit you. Something's wrong with your airplane. You got to avoid something, some terrain, something, an emergency. Something bad is going to happen. You do not just fly your aircraft into danger. Do what you have to do for the safe completion of the flight. Figure 60. How should the 500-pound weight be shifted to balance the plank on the fulcrum? Okay, we finally got a weight and balance problem. Okay. The 500-pound weight. Okay. Okay, how should we shift? How do we shift the 500-pound weight to get it to balance on the fulcrum? Okay, so we've got 500-pound weight is the weight on the left. Okay. We've got a 250-pound weight on the right. We've got the plank itself, which its CG weighs 200 pounds, and its CG is at 15. So 15 inches to the right. Okay. So we'll say, so this is a weight and balance problem. So we just set up the way we would any weight and balance problem. Item. Okay. And then what's the formula for weight and balance problems? Weight times arm equals moment. You write it out on the sheet. Item. Okay. 500-pound weight. Okay. Okay. Weight. We know it's 500 pounds. Arm. Well, we're not sure where we're going to put it in the end. They said, where do you want to put it? Okay. It starts at 15, but we're going to say, okay, it's to the left of the fulcrum. You see that as that little red triangle at the bottom, minus, and we're going to call it X. Don't know where to put it exactly. Okay. We're not sure where to put it. Okay. Is equal to the moment. Well, 500 times X minus 500X. Item 250-pound weight. Weighs 250 pounds. The arm is it's to the right. It's at 20 inches. You can see the 20 above. Okay. 20 inches. Okay. 20. Okay. Go to this guy right here. 250 pounds. Oops. 250 pounds times 20 inches. 5,000. Use your 4-function calculator. That's your moment. Okay. And then the last one is the plank itself. Item 3 is the plank. Okay. It weighs, let's move that over slightly, 200 pounds. Okay. 200 pounds. And it's to the right, and it says, and you can see 15 inches. Okay. Times 15. Weight times arm equals moment. Okay. So then we just use the calculator again. 200 times 15 equals 3,000. Okay. So we add up the moments. And if it balances, the moment is 0. If it balances out, the moment is going to be equal to 0. So let's add up those moments. Negative 500x plus 5,000 plus 3,000 equals 0. Okay. Just set it up like a normal weight and balance problem. Okay. Item is, and then what it is, the weight times the arm is equal to the moment. And I've done that for each of the weight, the 500 pound, the 250 pound, and the plank. Okay. And then I just sum them up. Okay. Write it out. 500, negative 500x plus 5,000 plus 3,000 equals 0. Okay. So I could say 5,000 plus 3,000, that's 8,000. And then I'm going to move the 500x to the other side. So we have, because it's negative 500x. So I'm going to say 8,000 divided by 500 equals 16. 16 inches. Let's go back to the question. It says, and then look at it. It's normally, the 500 pound weight is normally at 15 inches. Where do I want it to be? Okay. But I want it to be 16 inches from the fulcrum. 1 inch to the left. Well, that's correct. 1 inch more to the left would put it at 16 inches. 1 inch to the right, that would put it 14 inches. Nope, doesn't balance. 4.5 inches to the right, that'd be way far. Nope, nope. You set up the problem correctly, it's very easy to do. Okay? If you don't set up the problem right, you're gonna waste a lot of time on it. And you can always put these number problems, you can put them to the very end. Okay? You can mark them on the test and come back to them later. It's not like you have to answer them exactly in order. You can go out of order. That's fine. Okay, just come back to them, make sure all of them are answered. You get no point. You get no penalty for guessing. Okay, you need to get the right. You get penalized for leaving things blank. That's what you get penalized for. The lateral dimensions of Class Delta airspace are based on the number of airports that lie within Class Delta airspace, 5 statute miles from the geographic center of the primary airport. The instrument procedures for which the controlled airspace is established. From the geographic center of the primary airport. It's really based on the instrument procedures for the airport. Okay. Okay, when departing behind a heavy aircraft, the pilot should avoid wake turbulence by maneuvering the aircraft. We already talked about this. Above and upwind. Below and downwind? No, that's dangerous. Above and upwind? Yes, that's safe. Below and upwind? No, do not ever go below the heavy aircraft. Always go above. Okay. And depending on where your glider club is, you may be flying around traffic. Or if you have an emergency, you may have to land at a different airport with other traffic there. Referring to figure 52, where is Loop City Municipal located in relationship to the city? Oh, this is going to be an airport facilities directory, the chart supplement. Okay, where is it located in relationship to the city? Okay. Loop City Municipal. It is 1 mile northwest. It already says 1 mile northwest. Okay. It just tells you right at the beginning where it is in relationship to the city. 1 mile northwest. Northwest, approximately 1 mile. Boom. Refer to figure 55, illustration 3. means cut, stop, cut, stop, release the tow line, or stop engine now. Okay, he's drawing across his neck. Stop, cut. Calculate the weight and balance of the glider. Refer to figure 55. Calculate the weight and balance of the glider and determine if the CG is within limits. Apply its force. 100 on the forward seat is 160 pounds. Okay, in the rear seat, 180 pounds, 185 pounds. Okay, forward and rear. Okay. Okay, item, weight, times arm equals moment. Okay, and then we'll sum it all up. View the figure. Hey, look. Station diagrams. Okay, let's go in there. So, rear station. Okay, put that with the second item there, the rear person. 74.7. Front is 43.8. Let's find what the empty weight of the glider is. Okay, put that as our last item, the glider. Okay, is 610 pounds, and its station is 96.47 inches. Okay. So now we just do weight times arm equals moment. Get towards the end here. 160. Oops. Come on. Why don't you do what I want you to do? 160 times 43.8, 7,008. 185 times 74.7, 13,809.9. And then 610 plus times 96.47, 58,846.7. Okay, let's add up all the weights and add up all the moments. 160 plus 185 plus 610, 955. Okay, add up the moments. 7,008 plus 13,819.5 plus 58,846.7. Okay, 79,474.2. Write it down. Divide by that 955 gives us a new CG of 83.43. Okay. Answer CG. Yep. 71.46. Nope, that's not what we got. CG 79. Nope. 83.43. That's exactly what we just got. We got the new CG. And after the datum and within limits, we got 955 pounds was the weight. And it says the maximum gross weight on our little fake little Grobe 103 is 1,040 pounds. So we're definitely within the limits. Minimum distance from clouds required for VFR flying on an airway below 10,000 feet. We've already had this question. So if you have the same question twice, they just ask you it in different ways. Just be used to it. Okay, so we're below 10,000 feet. That's a really question. Is we're below 10,000 feet and we're in controlled airspace. Okay, so that's going to be 500 feet below, 1,000 feet above, 2,000 feet to the side. Okay, remain clear of clouds. Nope. 500 feet below, 1,000 feet above, 2,000 feet horizontal. Yep. 500 feet above. Oh, that's crazy. No. 1,000 feet below. Nope, that's backwards. They're trying to make it look similar, but not exactly the same. Okay, a couple more left. Refer to 68. The line from point A to B of the wind triangle represents true heading and airspeed, true course, or ground speed. True heading, true course, or ground speed and true heading. Okay. Okay, from A to B. Okay, from A to B. Okay, so you can see here's the little airplane from C to B. That's where it's traveling over the ground. Okay, you need to use this wind triangle properly. That's where it's that's your ground speed right there from C to B. But we're talking A to B. Okay, A to B is what the airplane is actually doing through still air. Okay, C to A, that is your that is your that's your wind component that he's fighting against. See, he's even turned slightly to the left in both parts. He's correcting from this wind that's coming from his left side. Okay. A to B represents his airspeed. Okay. The other was say ground speed. Nope. That's where the airplane is. Look where he is over the ground. That'll give you ground speed. This is airspeed. Okay. Which statement about longitude and latitude is true? Longitude and latitude are parallel to the lines of longitude are parallel to the equator. No, longitude, long lines, long longitude go up over the pole. They're all the same length. They're all long. Lines of longitude cross the equator at right angles. Ooh, that one. 0-degree line of latitude passes. No, that's longitude. They're trying to get confused on that. Figure 62 in flying the rectangular course. When would the aircraft be turned less than 90 degrees? So they're going to show a rectangular course, which is similar to our traffic pattern. These are ground reference maneuvers normally used for airplanes, but we still fly traffic patterns every time. So we still do a rectangular course, even if it's not a maneuver we have to demonstrate. Okay. In flying the rectangular course, when would the aircraft be turned less than 90 degrees? Okay. And the thing is, there's a wind coming from here. Okay. So they say corners 1 and 4, 1 and 2, or 2 and 4. So which corners is it? Okay. If we're flying along this line here on the bottom, okay, we're going to be flying pointed slightly into the wind. So when we come over to 4, if we're already flying kind of at an angle here to counteract for the wind, then we have to turn less than 90 degrees. Okay. If you're coming up here and if you turn to get counteract into the wind, okay, you're going to have to turn again less than 90 degrees because you always still want to be pointing into the wind. If you're pointing into the wind over at 2, then you're going to be pointing straight down to go with the wind. So you actually turn more than 90 degrees. And here you're going to have to turn more than 90 degrees because you have to point slightly into the wind. Okay, so when do you turn less than 90 degrees? Corners 1 and 4. 1 and 4. 3 more left. If the temperature dew point spread is small and decreasing and the temperature is 62 degrees, what type of weather is most likely to develop? Okay, so it's above freezing, 60 degrees Fahrenheit. Freezing point is 32. Okay. The temperature dew point spread is small, so you're probably going to get clouds soon. Okay. And the temperature is 62 degrees. What weather is most likely to do? Freezing precipitation. We're above that. Okay. Thunderstorms. No. What do we need for thunderstorms? We need a lifting mechanism. We need unstable air. They don't say anything about unstable air. And you need moisture. Okay. Doesn't say anything about that. Okay. What type is most likely to develop? Fog or low clouds? That's what it is. Okay. The minimum allowable strength of a tow line used for an aero tow of a glider having a certificated gross weight of 1,040 pounds is, so remember, a tow rope has to be between 80% and 200%. So the minimum strength is 1,040 pound glider, is what they just told us, times 0.8, 80%. 832 pounds. Boom, right there. How will frost on the wings of an airplane affect takeoff performance? Not good, I can tell you that. It's never going to help it. Frost will disrupt the smooth flow of air over the wing, adversely affecting its lifting capability. That can help. That can absolutely happen. Remember, frost. It not only does it change the wing airfoil shape, but it also adds weight. It's ice of any kind is double bad. Frost will change the camber of the wing, increasing its lifting capability. Increasing the lifting capability, improving it. No, frost is never good. Okay, increasing. That's not right. Frost will cause the airplane to become airborne with a higher angle of attack, decreasing the stall speed. That's a benefit there. Oh my gosh. No. Decreasing the stall speed. No. Disrupt the airflow, adversely affecting the lifting capability. Always bad. Always bad. Oh, holy cow. That was it. That was question 60. It's been 1 hour, 37 minutes, even with all the discussion. Okay. Let's grade it and see what I got. Grade the quiz. 93%. Okay. I missed one, two, and four of them. Two, three, four. Missed four of them. Okay. I haven't done these questions in a long time. Which gazelles through the information frost? Illustration number two. Okay. Well, that's not bad. Okay. If you are in the 90s each time, you're gonna do just fine. I'm gonna have to obviously there's some of these that I need to keep going over, but I am pretty happy with that. I'm going to include some links down below for this one to show what it some of the items that I used for the test, so that way you can get those. If you found this helpful, leave a comment and say if you want me to take any more tests, and we can do it live. Or if you want help on any of the knowledge questions, we can do that too. The point of this office hours is to help people get towards their glider goals so they can um, progress easier and faster. But at 93.3%, I'm pretty happy with that for the first go on this. Okay. Again, if you have any questions, leave them down below and I will respond to them. Everybody have a good day. And if you want me to do more live streams, office hours like these, just let me know and we'll do that. Okay.